This is a video demonstration of a home-built 8-bit processor that can take the place of the Z80 processor in the CPUville Z80 computer kit system. The processor is made from 3 different circuit boards. This is the arithmetic logic unit. This is the data path that contains the registers and multiplexers, and this is the control logic. This is a register display that shows the activity on the registers in the data path. The computer is made out of 74 LS series TTL integrated circuits, and I used the wire wrap prototyping technique to make the parts. This is the original Z80 computer kit. Right now it has a Z80 processor plugged in and a EEPROM that runs Z80 code. It's currently executing on a very slow clock a program that I call Count to a Million. This program runs an internal counter 16 times, and after 16 times it increments a 2-byte counter that's displayed on these 2 ports. So it's been running for a while, and right now it's up to 4. This is the bus display, shows the activity on the system buses, and eventually it'll reach another count, so now it's up to 5. It takes about 30 seconds to count, to do this 16 times before it increments this counter once. So to get all the way up to here, 16 times 65,000 is about 1 million. So that's why I call it a Count to a Million program. If you run the same program on fast clock, a 2 megahertz clock, which is the natural clock cycle for a Z80, you can see, of course, it counts quite quickly up to 1 million. This Count to a Million program was demonstrated on the original video that I made with the first prototype of the computer kit. I can connect the homemade 8-bit processor to the Z80 computer kit, just to remove the Z80 processor from the kit. And remove this ROM, which has Z80 code in it, because the 8-bit processor has its own machine code and doesn't understand Z80 code. And I have this fairly clumsy adapter here, but it does work, that I can use to connect the computer, the 8-bit computer, to the Z80 system. And I have a EEPROM that contains correct machine code for the 8-bit processor. The processor works better if I connect the power supply directly to it rather than have the power come through the rather clumsy adapter that I made. The EEPROM has a Count to a Million program in it, but with code that's appropriate for the processor. So I can take the computer out of reset and we can see the Count to a Million program being executed, again using a slow clock. In this case, the clock is on the control board because the current wiring configuration doesn't allow me to use the clock that's on the Z80 system board. Now in this case, again, it counts 16 times and then increments a 2-byte counter and will display the result on here. You can see the accumulator register over here counting down. When it gets to 0, you'll see the first byte appear over here, the first increment over here. And again, as with running a Z80 processor, you can see the activity on the system bus. This is a display of the current state that the control logic is in. And so we're again counting down another 16 for the next one, 3, 2, 1, 0, and we'll get an incrementation over here to 2. And so that's working the Count to a Million on a slow clock using the 8-bit computer. Now if I turn on the fast clock, you can see the count to a million program going quickly, and again the processor runs at 2 megahertz. So just like the Z80 processor, you can see it counting to a million pretty rapidly. Now to show that this is a proper computer processor, I'm going to run a different program. This program will display the highest factor of an 8-bit number that's entered on these input switches other than the number itself. So if you enter a prime number, it'll factor it and show 1 on here, and any other number it'll show the highest factor. I do this program with all the new computers I make in honor of the first program run on the first stored program electronic computer, which was the Manchester Mark I. So we'll take it out of reset and run the factor program. So if I put in a number on these switches, say 7, the output is 1, showing that that's a prime number. If I put in 15 or 0F hexadecimal, the result is 5. If I put in, say, 12, displays 6, and so forth. So you can see it's factoring these numbers, and that, I hope, proves to anybody watching that the processor is not just a fancy counter. It is a true computer processor. So that concludes the demonstration of the 8-bit processor that can take the place of the Z80 in the CPUville Z80 computer system.